Okay, so let's begin with the last class we discussed about the zeroth law, and let's continue from there. So zeroth law we said already. So how it is, and what is its practical implications, or how it is useful in thermodynamics, right? So zeroth law, what it says is if two bodies are separately in thermal equilibrium with another body C, then we can say that they are in equilibrium. The two bodies will be in equilibrium if they are brought in contact. Okay, so when I say equilibrium means they are at the same thermal level, right? So this thermal level is a little difficult concept to understand. As lectures progress in the subject, you will understand what it is. What is thermal level? Thermal level is like you can correlate it with like the something like an potential wealth, like whether a person is rich or poor, something like that. Okay, so if thermal level is high, means the body is capable of giving up energy in the form of heat. If thermal level is low, means this body is capable of receiving the energy. So heat always flows from a high thermal level to low thermal level. Okay, a body at high thermal level will transfer the energy in the form of heat to a body at a lower thermal level. Okay, so when we say, okay, fine, in a layman's language, it is heat always flows from a hot body to cold body, right? But then we cannot quantify it. It flows. Then how much it flows? Okay, what is the difference? If the what is the degree of hotness? Right? I want to measure what is the degree of hotness, how much hot it is. So this quantification is not possible. That statement only says heat flows from high temperature body to low temperature, or a body at higher thermal level to body at lower thermal level. So this is what zeroth law gives. Now let's, if you see that if the two bodies are at the same thermal level, then there is no heat transfer. They cannot exchange heat. Right? Energy will neither flow from this to that or that to that. Right? So this is what it says. So bodies are in the thermal equilibrium if both have a same temperature reading, even if they are not in contact. Okay. So in other way of saying that the zeroth law is two bodies are in the thermal equilibrium. I can say that, right? I need not bring them in contact to verify whether there is a thermal equilibrium or not. What I can do, I can separately measure temperature of two bodies. If I find that temperature reading is same, then I can conclude that two bodies are at the same thermal level. They will be in thermal equilibrium even if they are brought together, right? Without whether something, two bodies are in thermal equilibrium or not, how will you come to know? By bringing them in contact, right? If you bring them in contact, if there is no energy flow, then I can say there is no, they are in a thermal equilibrium, right? So this I can do it without bringing them in contact by using a third body, that is temperature, the temperature measuring instrument. Okay, so the temperature reading thermometer, right? So using that, I can say that if the two bodies show same temperature, then I can conclude that the two bodies are at the same energy level, or same. Their two bodies are in a thermal equilibrium. So what is temperature? Temperature is associated with the ability to distinguish hot from cold. What is temperature? Temperature is a quantity or parameter or property which is associated with the ability. What ability has this property? This property has the ability to distinguish hot from cold. Right? When two bodies, some, one of you, all of you, please switch off your microphone. Someone is switching on his microphone. There's a disturbance. Can you hear me? Who's that? Pramod? So So what is temperature? Temperature is associated with the ability to distinguish a hot from cold. When two bodies are at different temperature are brought in contact, after some time equilibrium is established between two. This is what we said, right? So now the temperature says if the property of temperature is such that if two bodies, if you measure that without bringing them in contact, you can say that the two bodies will be in thermal equilibrium if the measured temperature is same. If both are at same hot or same cold, right? Both the coldness or hotness is same for both, right? So this measuring, the temperature gives us ability to measure how much it is, right? To what extent it is cold, to what extent it is hot, right? That ability to measure, quantify is given by the temperature, like rich, poor, right? So how much rich he is, then it's very difficult to quantify, right? You can say only is rich, but how to measure the wealth? So money is a measure of a wealth. Money gives you ability to measure, quantify how much a person is wealthy, how much he is poor, right? Like that. So similar to here, similar to that, temperature is a property which is used to measure the hotness or coldness of a given body. Okay. So why it is important for us whether something is hot or cold? Why you want to know? Because two bodies, if they are at same thermal level, they don't exchange heat. If the two bodies are at different temperatures, they're at different thermal level, then they exchange heat. And heat is a form of energy. We are interested in energy study, right? Heat is a form of energy, and we are interested in a study of energy. We said at the beginning, we said thermodynamics is all about what? Energy and its interaction with mass, right? Energy interaction and its manifestation. When a mass interacts, mass receives energy or gives off energy, what changes it experiences, right? What it manifests in is this is something we are interested in, right? So let's go to thermometer. Then what is a thermometer? So in order to obtain a quantitative measure of temperature, a reference body is used. Thermometer is nothing but a reference body. In order to measure quantitative, in order to obtain a quantitative measure of temperature, a reference body is used, and a certain physical characteristic of this body, which changes with the temperature is selected. Okay, there is some mistake there. Please note down this with the temperature. One word I have to add. Okay. So in order to obtain quantitative measure of temperature, a reference body is used, and a certain physical characteristic of this body, which changes with temperature, is selected. Okay. So here what we want, why we are interested? Because we are interested, temperature is a measure of hotness or coldness. Now I want to measure the temperature. How to measure the temperature? I use thermometer. What is a thermometer? Thermometer is in order to obtain a quantitative measure of temperature, a reference body. What is thermometer? Thermometer is a reference body. It is nothing but another reference body. It is another body, another mass, right? There are two masses are there, one mass, so whatever it is. There is one mass or two mass, and n number of masses are there. I want to measure their temperature. Like human body is a mass, right? You want to measure the human body temperature, or you want to measure a liquid water is there, or ice cream is there. I want to measure it's a one body, right? I want to measure its temperature. What it is? What is thermometer? Thermometer is again another body, right? If you want to measure ice cream temperature, then ice cream is one body. Thermometer is another body, right? So this thermometer, what is it? What is the difference between temperature, ice cream and thermometer? This thermometer has a characteristic, right? There is some physical characteristic of the thermometer which changes with the temperature, right? Which changes with temperature or thermal level, right? So what happens if you bring thermometer in contact with ice cream? So let's say thermometer is at room temperature. Room temperature is more than the ice cream temperature. Now room temperature. No, so what happens when you bring a thermometer in contact with ice cream? Thermometer is at higher temperature. Ice cream is at lower temperature. So two bodies come in contact. When the two bodies come in contact, what do you expect? Heat transfer should happen, right? Energy will flow from a high temperature body to low temperature. So now what happens? Heat will flow from thermometer to the ice cream. So now what happens? Owing to that, thermometer temperature will decrease. So after some time, it will become equal to the temperature of ice cream. Right? It will give some time, it will become equal to the ice cream temperature. Now, when the thermometer was at a high temperature and Now the thermometer is at low temperature. There are two states. Thermometer has changed its state from a high temperature state to low temperature state. When it changes state from high temperature to low temperature, something changes. What is that change? Right? So anything that changes with temperature, we are interested. If you take a mercury thermometer, for example, all of you have seen mercury thermometer? Can you hear
Yes,
me?
sir.
Okay. What happens in a mercury
Yes,
thermometer?
sir.
What do you do with thermometer? Can anybody respond? Have you used thermometer?
Yes, sir.
Where you have used? What you have done with thermometer?
To check the temperature.
To check the temperature.
Okay. When did you check last time the temperature? Last time when did you use thermometer? Have you used or not? Have you had
Fermi
thermometer in
energy
hand?
experiment.
Sorry?
Fermi energy experiment in physics cycle. First
Physics
year.
cycle. Okay, very good, very good. So what did you measure? Temperature of what did you measure there? You use thermometer to measure something, right? Temperature of something.
Water.
Huh?
Temperature of water.
Water, right? So you measure the temperature of water. What did you do? You took thermometer and dipped in water, right?
Yes.
Yes or no?
Yes.
Okay. So before dipping in water, you looked at the thermometer. There's a red line, right? Vertical line. Yes or no? Yeah.
Yes.
It's a glass tube, and there's a markings are there. Millimeter markings are there, right? And you have a red color. You see something red or silver white. What it was? Red was there. What was the color inside?
Red.
Red. Okay.
That's the color.
Silver white, whatever it is. Okay. So there was something was there. It was at some height. It was at some reading. When you kept in a hot water, or let's say it was that water was hot water or cold water. Room temperature water was hot. What was the temperature of water? Higher or lower than room temperature? When you did experiment.
Higher than room temperature.
Higher than the room temperature.
Higher than the room temperature. So you took thermometer, you found that the reading was something, right? Maybe 32, 35, depending on the day you measured. Then you kept the thermometer in the water, right? So when you kept thermometer in water, that thermometer bulb we call, where you have this mercury. So when you kept this in bulb in the water, so you saw that the mercury level started rising. Yes or no?
Yes.
Right? It increased or decreased?
Increased.
Increased. So when the temperature of the thermometer changed, something changed. What changed? Level of the mercury
Level of mercury.
changed, right? So level of the mercury was at some level initially, at a lower level. When I brought it in contact with hot water, level of the mercury went up, right? So similarly, if you take the same thermometer and keep it in ice cream, what would you expect? Let's say mercury initially is at room temperature 35 degrees, and you keep the thermometer bulb, mercury level
decrease.
decrease, right? It will fall, right? It will reduce, right? So here, high level of the mercury is sensitive to the temperature, right? So level of the mercury is a characteristic, right? Is one characteristic which is dependent on the temperature. There is a one-to-one correspondence. For every temperature, there is a height. This height and temperature are having one-to-one correspondence. So for a given temperature, fixed height, it will not be taken. Whether temperature is you measure in India, Africa, or Australia, for this temperature, height will be same. Mercury height will be same. It will not be different. You take this thermometer to anywhere around the world. For a given temperature, the height of the mercury is same. It is a one-to-one correspondence. One-to-one, when I say, suppose the height is say 10 millimeter at this temperature. For this temperature, 10 millimeter. For 10 millimeter, this temperature. This is one-to-one correspondence. No two values, right? So like that, such characteristic we look at. So if you look at the thermometer, it is the height of the mercury. But actually, it is not height of the mercury. What it is? Can anybody guess? Is it height of the mercury? What is changing there? When temperature changes, something changes. So you see there is a change in height of the mercury. Is it correct? Height of the mercury is changing or something else is changing? What is changing?
Property of the
Mercury
mercury.
changes into liquid, whatever solid is there.
Okay. Mercury.
Property of the mercury changes.
Which property?
Volume.
I said. Oh, somebody said something. Somebody whispered something. Who's that? Somebody
Volume.
said volume. Right. Okay. It's not height. Volume decreases. Volume changes. Volume increases with the temperature. Volume is a function of temperature. Volume is linearly proportional to temperature. Right? You understand? Volume is a direct function of temperature. So, given temperature, fixed volume. If you take a matter, any material, it has got a fixed volume for a given temperature. It will, wherever you do it, wherever you measure, volume is fixed for the given temperature. If temperature changes, volume changes. If temperature increases, volume increases. If temperature decreases, volume decreases. Right? So here, mercury level, mercury volume increases or decreases depending on the temperature. So when you brought the mercury bulb in contact with hot water, the volume of the mercury that exists in the bulb, its volume increased now. So when the volume increased, what happened? You know, if you have seen the thermometer, inside it's a cylindrical tube inside, right? So that cylindrical gap is having a constant area of cross section, right? Diameter is constant. The pipe inside cylinder is there, hole what you have, cylindrical hole inside glass tube is a constant. Cross section area is constant throughout along the length of the thermometer. It is a fixed, it's not changing. So what happens here when you have a mercury? The mercury volume is increasing, but it is enclosed in a glass tube. Glass is a very rigid body, right? Its volume does not change. Of course, volume of a glass also increases when you increase the temperature. But compared to mercury, the increase in volume of the glass is negligible. You can neglect it. Okay? But strictly speaking, volume of glass also increases when temperature increases. Okay? Okay. So that forget it now. For time being, you take it for granted that volume of the glass as well as the cavity inside, right? The hole that is there, cylindrical hole that is there is constant. Volume is constant. Okay. So now what happens? This mercury is there in the bulb. Its volume increases. It has to increase, but it is constrained everywhere except, right? Except it is constrained from expansion. It is not allowed to expand anywhere except to rise in the column, right? So all the two direction it is constrained. Vertical direction it is allowed to rise, right? In three direction, volume expansion happens in three direction. But if it is constrained, right, it is not allowed to expand in two direction. X and Y direction it is not allowed to expand. Laterally it is not allowed to expand because there is a wall of the mercury tube is not allowing it to expand. It's a rigid body. It does not allow it to expand. So now what happens? Volume increases by increasing the height. Right? We know that volume of the liquid inside the cylinder. If you take any cylindrical object, its volume is, what is the volume of a cylinder? Can anyone tell me? Volume of cylinder equation. Anybody? Cylinder volume. Anyone know cylinder volume? No? Any response? Prerana? Are you with me? At least say no, we don't know. Don't keep quiet.
We don't know, sir.
Okay, fine, no problem. Say, say that. Nothing wrong there. If you don't know something, it's not a crime. Okay? I don't know many things, okay? In life. That's not a fine. That's not an issue. If you don't know, say I don't know. That's all. Okay. So when I say volume of cylinders, I'll tell you now. Now you will say, we knew it. Okay. Pi r square, cross section area into height. Pi r square h. Am I right?
Yes.
Yes or no? Pi r square into h. So now this pi r square, r is constant, radius of the cylinder pipe is a constant. Okay, so the area is constant, pi r square is constant. Only variable is h, right? So therefore, what happens? Mercury column height increases. Level of the mercury increases because the liquid mercury is not allowed to expand in other two directions. Only way it can expand, increase its volume is by raising the mercury, the column in the thermometer. So the thermometer mercury column increases when temperature increases, decreases when the temperature decreases. So now this height of the mercury column is a direct function of a temperature. The height of the mercury column is a direct function of a temperature. There is a one-to-one correspondence between temperature and the height. Right? So if you look at here, temperature, the characteristic that changes with temperature is actually volume. Which characteristic changes? Property that changes with the characteristic means property. The property that changes with the temperature is actually volume, right? But I am converting that change in volume into change in height. How I am converting? By constraining the liquid to expand. I am not allowing the liquid to expand in two directions. I am only allowing the liquid to expand in one direction. Therefore, I am converting a change in volume into change in height. Okay. Now the change in height becomes a measure of a temperature. Right? The height of the mercury is a measure of the temperature. You are not measuring temperature exactly. What you are measuring is height of the mercury. The height of the mercury represents the temperature of the material. What is temperature? Temperature is the thermal level of the material. Okay, you understood? Right? So this temperature, there is no equipment there you can directly measure. Right? We know that temperature is there, thermal level is there. Thermal level is high, low. We know that, but you can't measure it directly. Only indirect measurements are available like this. Okay? What I'm doing, indirect measurement. What I'm doing, when the temperature changes, something changes. I find out that. What is that? Here I found out that volume. Volume changes with temperature. Volume is a direct function of temperature. Now what I do, I constrain the liquid from expanding in all direction. I allow it only to expand in z direction. Right? I allow only height to increase. So then height of the mercury is a function of temperature. So by measuring height, I say that I have found out temperature. Right? So it's something like intelligence. We know, all of us know intelligence, right? We know intelligence. How to measure intelligence? Can anybody measure intelligence? Some people are intelligent, some people are not intelligent, right? Some people are very intelligent, right? So how to measure this? Quantify. IQ, they say, intelligent quotient, right? How to measure it? Just by looking at the face, can I say this fellow is intelligent, that fellow is not intelligent? Is it possible? Not possible, right? So how we do it? How we assess intelligence? By we measure some things, okay, which are function of temperature. So you stimulate person, you ask him question. So look at the response. What answer he gives. So prepare a questionnaire. So give different questions, right? So an intelligent fellow will respond in a different way compared to a dull fellow, right? So looking at the response, I come to a conclusion that what is his IQ or what is the IQ of that fellow, right? So like this, intelligence can directly cannot do. We know that it is there, but we cannot directly measure it, right? The temperature is there, but I cannot directly measure it. So I have to look at something which gives the measure of temperature. So here it is volume in mercury thermometer. Volume is the measure of temperature. Volume is converted into height. Height is measured, and then we say it is a measure of temperature. Okay, this is the philosophy of the thermometer. Any thermometer you take, it is basically one or the other characteristic that we look at, which are functional, which are dependent on temperature. So the change selected, the change in selected characteristic, in is missing here. Okay, the change in, one word is missing here. Please note that the change in selected characteristic is taken as an indication of change in temperature. Okay, the change in selected characteristic. What is change in selected? What is selected characteristic? Mercury, if it is mercury thermometer, it is height of the mercury column. The change in height of the mercury column is taken as indication of temperature. This is the philosophy of the thermometer. The selected characteristic or property. The selected characteristic or property. The selected characteristic or property is missing here, is called thermometric property, and the reference body is called thermometer. Okay, the selected characteristic is called thermometric property, and a reference body is called thermometer. So this is the definition of a thermometer. This much you should be able to write if somebody asks what is temperature, short note on temperature. You should be able to write all this. Okay. If it is only for 1 mark, you write this here. Okay. First paragraph. If it is a 2 marks, you write this much. Okay. All these 3 sentences. Okay. So like this, you should be able to write elaborate depending on what is the marks allotted. Okay. So very common thermometer. Suppose the same question is for 3 marks. Then write this below example with example. Right. 1 mark only this per sentence. 2 marks add these 2 sentences. 3 marks add 4 sentences. Okay. A very common thermometer consists of a small amount of mercury in a evacuated capillary tube. Understand? A very common thermometer consists of a small amount of mercury in a evacuated capillary tube. That tube, no, that inside the thermometer tube is called capillary tube. Evacuated capillary tube. So because the tube above mercury there is no air. It is evacuated. Vacuum is there, right? Suppose all of you have seen thermometer. Other end is closed, right? Sealed totally, heat sealed. By heating glass is melted and sealed. Have you observed it? All of you have seen thermometer. At the top end it is sealed. Yes or no?
Yes.
You have observed, right? All of you observed it. It is
Yes,
heat
sir.
sealed. By melting it is sealed. So the air cannot enter inside. It is evacuated. Vacuum is created and then sealed. So why vacuum is created? If you don't create vacuum, what will happen? Suppose the mercury level increases. Let's say temperature increases. So now there is a gas. Air is there above the mercury. Other end is sealed totally, right? So air cannot escape. So what will happen? The rising mercury level will compress the gas, right? So gas pressure will increase, right? When the gas pressure increases, suppose the temperature increases too much and pressure becomes very unbearable. What will happen to the glass tube?
It will break.
It will explode. Yes or no?
Yes.
Yes, no, right? If you take one glass bottle, tightly close it and put it in fire, what will happen? Dub. Yes or no? Have you experienced
Yes,
it or not? Campfire you have done? No?
Yes.
Yes.
Scouts and guides. Anyone has
Yes,
done
sir.
campfire? Huh? Have
Yes.
you put a closed bottle inside? No, no. If you put it, it will explode. All fire will be on your face. Okay, don't do that. I'm not suggesting it. Never do that. Don't put the closed bottle in fire. Never do that. It will explode. Okay. Suppose this cold drinks tins are there. You put it in fire. What will happen? It will explode. Okay. So don't do that. Right. So here same thing happens in a mercury thermometer. It is evacuated. So there is no pressure rise. Okay. Only volume of the mercury increases. There is no pressure increase inside. So to avoid an explosion of the thermometer, it is evacuated. Therefore, it is called evacuated capillary tube. Okay, capillary tube is a name used. Capillary is a capillary action is that let's not discuss it. There is a different field of science. Capillary means just for timing. I'll tell you. If you take if you take water in any small cylindrical vessel, you see that water is at the edges. When it comes in contact with the surface, it is slightly up. It is not at the same level. The rest of the water is at certain level, but at the water where it touches the surface, it is slightly above. That's why there is a because water has got a affinity for the surface, so it slightly rises above. This is called capillary action. If you also studied biology in +2, how these plants take water from the ground. It is by capillary action. Okay? Or suppose if you take this light, when you light lamps in temples, there's a wick is used in oil, right? That the oil rises to the and burns, right? Then, so how it happens? Oil rises through the wick through capillary action. Okay? So that's called capillary action. Let's not go into that. So that is called a capillary evacuated capillary tube. Okay, fine. Am I clear here? Okay, then let's proceed to the next step. In this case, extension of a mercury in the tube is used as a thermometric property. So height extension or a height of the mercury level is known as a thermometric property. This is a thermometric property. Okay. What is thermometric property? Thermometric property is a characteristic of a body which represents the temperature, which is a function of temperature. Okay. So the height of the mercury column is, or extension of mercury is known as a thermometric property. Measurement of a temperature. How we measure temperature? So one example I extensively explained it. What is that? By measuring the volume, we can measure the temperature. So a temperature, that is one example we looked at. So let's look at the general philosophy of temperature. Temperature of a system is a property that determines whether or not a system is in equilibrium with other systems. Okay, temperature decides whether a system is in thermal equilibrium with other system or not. Okay, if two systems are at same temperature, they will be in thermal equilibrium. If two systems are not in thermal equilibrium, if the two systems are not in at same temperature, then they will not be in equilibrium. They will exchange it, and then when they are brought in contact, they will exchange energy in the form of heat. Okay, so a body is at say 70 degree, whether measured by mercury in glass thermometer or thermocouple, it should be same, right? Whether I measure using a thermometer or I use a thermocouple. Thermocouple, I hope you have seen, all of you. So whether I use thermocouple or a thermometer.
What is thermocouple, sir?
You don't know thermocouple?
No, sir.
Then I will not explain. You have to tell me tomorrow. Okay, next class when you come back there, you have to tell me what is thermocouple, because you have studied this thermocouple long back. So I'm not going to explain this. Next class, all of you should explain what is thermocouple. Am I clear? Will you do it?
Sure,
Anybody can answer thermocouple?
It manages the heat.
What? It manages heat. My God. Okay. Then what else? Anybody else? Not correct answer. Wrong answer. Anyone else? Thermocouple? Can anybody tell me this answer?
Sensor.
Oh, no, nobody is there.
Sensor.
Oh, huh? Sensor. Okay.
Sensor.
Oh, okay, that's correct. It's a sensor. I know that. Okay, fine. It's correct. Partly it is correct, not fully. What is thermocouple? That I want. So, okay, it's an assignment for you. All of you write a brief note on the thermocouple and submit it. Am I right? Clear? Next, tomorrow itself you have to submit that. Okay. Find out. You read Google. You go to book. You refer to physics book. If you refer, you will find it either in first year or second year physics. +2, you must have come across the thermocouple, or in engineering physics also you will have this subject. Some topic on thermocouple is there. You refer first year PUC book or second year PUC book or engineering physics book. Somewhere you will find it. It is there. Okay, I'm sure of that matter. So you have to tell me. You just I need 4-5 line answer. I'm not looking at very elaborate answer. Okay, 4-5 line answer. All of you should send. Okay, so put it in the WhatsApp group. Okay, am I clear here? Is that clear?
Yes, sir.
Okay. Okay, thermocouple. I don't want to explain. Okay, I know. I'll not. You should. You find it out. Okay, fine. So thermocouple is there. It is it's like thermometer. It is used to measure the temperature. What thermocouple effect and all this you just find out. So this thermocouple, whether I use a thermocouple or a thermometer, it must be temperature measured must be same, right? Okay, that is a basic requirement. So there are 5 different kinds of thermometers are used. Okay, in science and engineering, we make use of 5 different kinds of thermometers are there. So one is the mercury thermometer. Okay, so what are the different kinds of thermometers? There are 5 different kinds of thermometers, each with its own thermometric property, as shown in the table below. So these different kind of thermometers are there. Each one has its own thermometric property. So the thermometric property is a property which changes with temperature. In mercury thermometer, it is the temperature that changes with the volume that, or the height of the mercury changes with temperature. Similarly, other 5 types of thermocouples are 4 types of thermocouples are there. They have some property, right? Here it is volume or height of the mercury. There it is something else which changes with temperature. Okay, what are those? Based on this, what is the principle they follow, and what is that they measure, how they measure? They are classified into 5 different types. So let's see what are those different types of the thermometers that are used in the day-to-day engineering and technical life. So these are some of the thermometers that you come across. First one is called a constant gas thermometer. Okay, constant volume gas thermometer. Okay, constant volume process you have come across, right? You have studied in physics and chemistry. At constant volume, if you change the temperature, what happens? Volume is constant, you are increasing the temperature. What changes? Suppose you have a gas, volume is constant, you increase the temperature. What will happen? Can anybody guess? Can anybody answer this question?
Pressure increase.
Pressure increases, right? So when volume is constant, pressure is a direct function of temperature, right? Okay. So you have natural gas equation, right? The ideal gas equation, sorry. PV equal to nRT. N number of moles and the universal gas constant are constants. They don't change. Okay. So PV equal to nRT. nR is constant. So therefore, if I keep volume also constant, then what happens? P becomes directly proportional to temperature T. Right? So therefore, what happens in a constant volume gas thermometer? Pressure is function of temperature, or pressure is a indicator of the temperature. The measured value of pressure is gives you the value of a temperature. Therefore, measured pressure is taken as a thermometric property. It is a measure of temperature. Okay. So the constant volume gas thermometer symbol is used T. Similarly, you have a constant pressure gas thermometer. Same thing here. If you keep pressure constant, if you increase temperature, what happens?
Volume increase.
Volume increases. So volume is a function of a temperature if a pressure is constant. So measured volume is measured volume will be the indicator of the thermal level or temperature of the body. Electrical resistance thermometer. Electrical resistance, you know, all of you. Everyone knows electrical resistance here, and they don't know. Yes or no? Please respond.
We know, sir.
You know
Yes,
it. What is
sir.
electrical resistance?
Resistance offered to the flow of current.
Okay. What is equation? You remember equation for resistance? What is symbol used for resistance? Which word you use for resistance?
Ohm.
Ohm is a symbol, man. Ohm is a unit to measure the
R is equal to V by I.
R is equal to V by I. Suppose you apply a voltage of V, then you get a current I. Then I say V by I is the resistance of the material. Okay. So here this resistance is a function of temperature. If you see any material, if you take resistance depends on temperature. If temperature increases, resistance also increases. So by measuring the resistance, you can measure the temperature. Okay. So resistance is known as a thermometric property here. So similarly, then there is a thermocouple, right? So what is thermocouple and thermo EMF? I will not explain now. You have to explain me.
Sir, it measures the temperature.
Okay, how it measures?
That in digits, sir. We have used it once
Where you used?
in the competition once in high school.
Okay, fine. That's fine. You have used it, but how it works, you don't know.
Not properly.
You should know, right? You find out. That's what I'm giving you an assignment. What is thermo EMF? Thermocouple, thermo EMF. I will not explain today. Okay. So there is something called thermo EMF is there. Thermal EMF or thermo EMF is used. That amount of thermo EMF, what is the voltage that is generated, is a direct function of temperature. Okay. How it is, what it is, you have to tell me. Okay. So here thermo EMF is the thermometric property in a thermocouple. Mercury glass thermometer, which we already discussed extensively. Okay, here it is length or height of the mercury is known is a thermometric property. So like this, there are 5 different types of thermometers that are used, which are used. This is not the end. There are many other types of thermometers are also available. Okay, so these are very commonly used type of thermometers. So nowadays there is a very common. Recently it has come up. It was not there earlier days. This thermography, they do this. This COVID, due to COVID and all, what they are doing, they'll hold some instrument on your head, direct some instrument to your head. Then they'll say what is your temperature. Right? There is a non-contact type of thermometer that is used for the surface temperature measurement. That is only surface temperature used. It is based on the emitted radiation. Okay? So that is another type of thermometer, which is has become very popular of late. Last 10 years. It was not there earlier. It is very popular nowadays. Okay. So standard fixed point. So now what happens? As I said, the temperature is a thermal level. So when I say thermal level, you have to measure. It's very difficult to measure. I said you can't directly measure it. Only what we look at is indirect indicators of the thermal level, and based on that we arrive. So then here there is a need to fix the point. Okay, reference point you have to fix, like height, height on Earth. Right? How it is measured? Any height is measured with respect to. Suppose somebody will say height of this dam. Let's say someone is there anyone from North Karnataka here? Because in South I don't know the dam heights. North I know. In my place Bijapur there is a place called Almaty. There is a dam. That dam height is 524 meters. Height of the dam is. Okay, 524. Anyone knows height of dams here? Nearby dams? Anyone has any idea?
No.
Nobody. Okay, fine. Let's then take example of only the Almaty dam. So the level of water stored in that dam will be to what level they store is they store it up to 524 meters. Okay, there's a limit. Anything more than that, if there is a water that is coming into the dam more than that, water out play mechanism, it can overflow. Anything that is more than that, it is allowed to flow over and flow downstream. Okay, this is the concept of any dam if you take. Okay? For that matter, any dam, not just the Almaty dam, any dam will have a height. Okay, fixed height. That will not change. Okay, fixed height. There is a maximum height. What I mean to say. If water level is more than that, it will overflow. If water level is less than that, then it will be stored in the dam. Okay. So that height, when I say 524 meters, 524 meters means approximately half kilometer. Yes or no?
Yes.
Okay, approximately half kilometer, right? So if you go to that dam and look at stand below the dam and look at the dam and say, you expect the dam to be 524 meters? When I say height of the dam, is it the height of the dam? Huh? Do you expect that? When people say height of the dam is 524, do you think you go measure from the bottom and find out the height of the dam will be 524 meters?
No, sir.
No, right?
No,
You can
not
half kilometer height dam will not be there. Have you seen any building half kilometer height? You don't have. No building will be a half kilometer height, right? You can't build such structures, right? Yes or no?
Yes.
Okay.
Yes.
So when the people say height of the dam, it is with reference to sea level. Okay. Height of the dam whenever people say it is above sea level at a 524 meters. Water level when it is maximum water level in that dam will be 524 meters above sea level. Okay. Why sea level is used? Why not bottom of the sea? Why we measure from the sea level? Why height is measured from the sea level, surface of the sea? Any idea? Can anybody say anything? So that becomes difficult. We don't know the bottom of the sea. There are many deep seas are there. People have not reached it. We don't know where the valley is there, right? So there is a reference is difficult to fix, but sea level is easy to fix. Sea level is same around the world. Okay, so that is taken as a reference. Anything above sea level is taken as a positive height. Anything below the sea level is taken as negative height. Okay, minus. So that is just a reference point. It has nothing to do with right. Negative height means what nonsense it is, right? I am saying height and negative, right? How deep I should say. Right? So negative height above sea level is called a positive, below is called a negative. Like that. It's just reference. I have taken it as a reference. Okay. So similarly, for temperature also we have to fix the reference, fixed point to measure, because we say thermal energy level, then I have to fix somewhere. This is so many degrees higher than that reference, so many degrees lower than this reference, right? This 0 degree is taken as a reference. It's a reference point. When we say 35 degrees, what it is? It is the temperature is 35 degrees above melting point of an ice. When you say -5 degrees, temperature is 5 degrees below, less than the melting point of ice. Like that, fixed points are used. Ice melting point is one fixed point. Like that, there are many fixed points. Different fixed points are used for science and engineering applications. So one more fixed point is the melting point of water was the common reference point that was used earlier, but there were some lacunas in this standard. This was not this standard was not complete for many applications. It was not sufficient to have the ice point was not sufficient. There was need to change, and people changed it. Looked at a different fixed point. Another fixed point that is used is a triple point of water. Okay, what is triple point? The state at sorry, there is a mistake here. This should be at A, not ATE. Okay, please note this. The state at which ice, liquid water, and water vapor coexist. Right? The state at which ice, liquid water, and water vapor coexist. At this state, the whatever temperature you will see is called a triple point, and it is fixed. It is same. If you find a triple point of water in America or in India, or you go to moon, you find out triple point, it will be same. It will not change. You go to Mars, anywhere you go in the universe, anywhere you go, triple point of water will be same. If all three phases of water are in equilibrium, ice, liquid, and water, that condition is known as a triple point, and it is fixed. It will not change. The temperature is only one. It is unique. It does not change. And this is taken as an international standard for the measurement of temperature. Okay. So why the ice point was not taken as a standard is the ice melting temperature is a function of a pressure. Okay. The ice melting temperature is 0 degree at atmospheric pressure. If it is 1 atmospheric pressure, then it is a 0 degree. Suppose you increase the pressure, right? Then ice will melt at higher temperature, not at 0 degrees Celsius. It will melt at a higher temperature. Suppose you decrease the pressure, right? You decrease the pressure to very low value. Then ice will melt at a lower temperature. You can make ice to melt at the lower temperatures, okay? Not at a 0 degrees Celsius. Even below 0 degree, it will melt if you decrease the pressure. So the melting point or boiling point of any material for that matter, not just water, are function dependent on the pressure. The melting point and boiling point of material is a function of a pressure. Therefore, it is not correct to use for many applications. It is not proper to use the melting point as the standard. So therefore, people shifted from the melting point of ice to earlier two points were used. The melting point of ice and the boiling point of water were used as these two standard fixed points for measure the calibration of a temperature equipment. But now it is agreed that the only one point is used, that is triple point of water. That is what it is. Triple point. Triple point is the state of where the ice, liquid water, and water vapor, all three will coexist. Right? What I mean when I say coexist? Suppose you heat the water. Right? You take water. All of you have done this. No? You do it. Hot water you want to do. Take it and heat it. So when you heat, what happens? Initially there is only water. Right? After some time, when temperature increases, water starts boiling. So when at boiling, both phases, vapor start coming from the water, right? Only when you boil water, vapor starts coming. So at that temperature, vapor and water are coexisting. They are in equilibrium, right? So at boiling point, water and vapor are in equilibrium. Similarly, if your ice is melting, right? When ice is melting, the water and the solid ice are in equilibrium, right? So similarly, you can have ice, water, and vapor. All three will coexist. You find that at some particular pressure and temperature, all three will be there. Ice will be there, vapor will be there, and water will be there. So like that, That condition is known as a triple point of water. That it happens at a unique temperature that is fixed. If this temperature is unique, wherever you go in the universe, not on Earth, not on any place you go, it is the same. It will not be changing. Okay, it is fixed, right? So, like this triple point of temperature is given a value. It's an arbitrary value is given. That value is given as 273.16 Kelvin. Okay, it's arbitrarily given. Okay, so then this is when you have this triple point, what happens? There's a gas thermometer is there, measuring equipment there. You find that the water, ice, vapor are in equilibrium. Measure that temperature and for that temperature value as a 273.16 Kelvin. Okay, this triple point is given a value of 273.16 Kelvin. This is the triple point temperature is standard and used for any application. I think we'll wind up now. I have some other work there. The university exam duty is there. Today we'll close the session. All right. So we'll continue in the next class. Is that fine? Are you happy?
Yes, sir.
Yes, sir.
Okay. We'll wind up the session now. We'll stop. Don't leave the session. I will download your attendance. Then you can leave. Yes. Downloading. Yeah. Done. Right. So your numbers are not increasing. Only 29 people are attending. Whoever is class advisor, CR, please. Oh, what is it?
No class advisor selected, sir.
Not class advisor. Class CR is not selected yet. Eh?
Class here, sir. Sorry.
No, sir.
Yeah, please, if your friends are there, tell them. If you know they are missing, attendance is compulsory. Then put huge penalty. It will be burden for your parents. You don't feel the pain, but parents will feel the pain when you pay penalty here. Don't do that. Okay? Tell your friends. Fine. Okay.
Yes, sir.
Any question? There are no questions. We'll stop this here.